All right, so this is going to be a quick video overview of section 1.3, algorithms in Python. So the goal of this lesson is to understand all information as bits. Now, bits is short for binary units, and we're going to go into more detail about what those are in this unit. And we're also going to transfer our understanding of algorithms to a new language. We've already done Scratch and App Inventor, so now we're going to use our understanding of algorithms from those languages to this new language, which is going to be Python. The hook for this unit is going to be the opportunity for students to solve interesting problems, including various games such as Mastermind, number guessing, and Hangman. Students are introduced to functional imperative and declarative programming paradigms with Python. Again, learning to use variables in the most common role. So those common roles that were covered in Scratch and in App Inventor will be revisited in this unit as well. Variable typing is introduced along with lists and list operations, and the lists are very similar to what we did in Scratch with lists, only it's going to be expanded upon a little bit more to do more data processing, which is basically the strength of Python. Students conclude this section with creating algorithms in Python to solve problems of their choice. So your project for this section is basically going to be solving a specific data calculation or data analysis using the power of Python. The schedule is as follows. So 131, we basically are starting with a section about abstraction. It's basically going to be going over how machine code works and how it's processed in a computer. You're basically going to be thinking like a computer for this first section. 132 is going to revisit those variables and introduce functions in Python. 133 is going to involve branching using conditionals and how that outputs to the screen. 134 is going to expand upon this branching, and you're going to have branching within branching, also known as nested branching, and also introduce some things with input, so getting the user to actually input something into a function of Python. 135 involves strings, which are a different variable type. Most of the stuff that we've been doing involves numbers. Strings are going to involve stuff with textual stuff, things that don't behave like numbers. That could be their data types that could be stored in variables. 136 involves different variable types of tuples and lists. They're very, very similarly related to, tuples are very closely related to lists, but they're a little bit different. 137 and 138 both involve loops, for loops, and while loops. For loops are basically loops that are going through a prescribed set of repeating. While loops are basically things that repeat based on a certain conditional statement. We're going to go over those in a little bit more detail in that section. And then it finally concludes with a project of your choice of using all the stuff that we learned in this section to create a project that basically solves some problem of your choice. The essential questions of this section are going to be, how can data be represented with binary? That's going to be primarily covered in this 131 activity here. How does abstraction make the software development process easier? So you're going to learn about how Scratch and App Inventor and Python, how that abstraction and how those languages abstract and how it actually makes the software development process easier or harder depending on what you're trying to do with your algorithms. The next one is, how can effective collaboration be achieved? You're going to be working in groups a lot on this section, so basically that's what that question deals with. And then, how does creativity play a role in algorithmic programming? So being creative, how are you going to be creating these algorithms to program basically some problem that we're going to solve? So that's basically section 1.3, algorithms in Python. If you have any questions about anything in this video, let me know.